Hey Andrew,
Hello, sir.
how are you doing?
Yeah, pretty good. Yourself?
Yeah, I'm good. Good.
I'm probably ready to be done with these late nights.
Hey guys,
Well, I am looking forward to getting my Monday evenings back for sure. Hey Morrow.
I am so sorry for
Happening.
disappearing completely.
You should have
Life's
done
No
so
other two
problem.
busy,
calls.
so busy. But today is, I understand Andres is joining, right? And I saw him like 30 seconds ago. So I wanted to be here too. I mean, he's so good. So good. I love him. Hi, yo.
Good afternoon,
Hey
or good
Ron.
morning, or good evening. Everybody's on different time zones.
We have the full array here
Yeah, Jackson's
Yeah.
about to go to bed.
for sure. Hmm.
Yeah, what time is it for you, Jackson, now? I see you take what? Oh, 11?
Yeah, well done.
Darn. There you go.
Exactly. What time is it where you are?
It's 7 p.m. here.
Okay. Where
Here
are you
now is
also?
Argentina. I know it's very confusing. Catch me if you can.
I was gonna see what time it was and then try to figure out every city in that time zone
Yeah, and
and
for
see
for
which ones you can
Andres, I
surf
think it's
in.
two. For Andres, it's significantly earlier. He's in Colombia. Uh, I know it's pretty early. Let's see. Or it's like 3 p.m. for him, I think. And he's a night owl. So.
Yeah, I just forwarded the link 'cause I'm not sure if he was on the Slack or not.
Yeah.
Send Andres a reminder just in case, because I saw him a few seconds ago. Let's see if he has the.
Hello.
Andres.
Welcome.
How's it going?
How are you?
You're doing awesome. I think we're all pretty excited to have you here.
Thank you.
Just before we get started, you probably saw when you came in, the meeting was being recorded. Usually, what happens is John, the head of the data science learning community Slack, will post videos so people who aren't able to make the weekly meetings can review. So I just wanted to double check if that's okay. If not, then we can tell John to not post this one.
It's absolutely okay.
Perfect. All right, I believe I should too. Awesome. Well, yeah, let's get started. Thank you a million times, Andres, for joining us. I think it's really cool to have someone. Like we said, we've been following along with the Rust book, trying to get our feet wet, and to have someone who's farther along in that journey, and especially who's worked at that intersection of R and Rust and seen how they can go together. I think that's really cool. So yeah, we're really excited to have you here.
Awesome. Thank you. So how should we go about this?
That's a great question. And whatever you're most comfortable with. I don't know if you have anything prepared, or we can just start throwing questions at you.
So first I would like to hear about yeah, I mean, I guess you guys just finished the Rust book, right? From my understanding.
Yeah.
So like before we get into like any questions for like having a little back and forth, I would love to hear you guys' like first impressions, kind of experience, kind of the decision making of why you guys decided to start getting into the Rust book in general, like just to kind of get a sense of what's going on here.
Yeah. Since I'm on mute, I'll go ahead and go first. So, I mean, I've been using R for quite a while now. I have over the years gone away from using R as like a data analysis tool, and so I've been much more on the software development side where I'm not really doing analysis, but I'm kind of building the tools that other people can do it. Um, so kind of going down that path, I just like more interested in software in general. And so I saw the book club happening. I was like, cool, another language. Let's see what this is all about. And I've heard about Rust all over the place. You know, blazing fast is kind of like the trademark now. Everything in Rust is blazingly fast. But yeah, that's where I'm coming from. And whoever else, whenever you're ready.
Yeah. I haven't done a lot with like low-level languages before. I did like a tiny bit of C when I was doing physics, like way back when. But I mean, really like a micro portion of it. And then have been doing lots of Python and R in the meantime, and just kind of felt last year like I kind of want to buff up my understanding of, you know, other languages, and specifically a low-level language and compiled language, and try to like kind of round out my overall expertise. And I think maybe, I mean, yeah, one of the interesting things that came about with Rust, or like with also the strongly typed nature of it, was all of the things that I've found myself coding around in R that kind of come in the package with Rust a little bit. So like I'm looking at all my unit tests and I'm like, all of this is just type safety, and I don't actually need to be writing all these tests when it just comes for free. And just kind of like some of the trade-offs that you get at like paying some of the trade-offs you get at runtime, at compile time, and those things were just like eye-opening and pretty huge for me. So yeah.
Yeah, I guess I can go next. I've had experience in compiled languages and strongly typed languages, C++ mostly, doing simulations and things like this in the past. Haskell for fun. I've never actually used it. Well, that's not true. I made one simulation one time for a client actually using Haskell. But that was more like, hey, I wonder if I could use Haskell to do this. And what I learned from that is don't do that again. So but my interest in Rust kind of stems from, well, I do a lot of R. I do more Python than R though. And recently I keep running into packages that are written in Rust. And I'm like, so that got me curious about it. For example, Polars, of course, is one of them. Then there's the UV package management system is another one. And then I do a lot of Bayesian inference. So there's this new sampler called NumPy that's also written in Rust. So I got really interested, like, why are all these people using Rust for these things? So I wanted to find out. It's pretty interesting. I listened to a podcast with the guy that did the NumPy thing, and it turns out he did that just for fun too, because he wanted to say, "Hey, can I do this? Can I write Hamiltonian Monte Carlo sampler in Rust?" And he did, and it turned out that while he was doing it, he came up with some new ideas of how to do the sampling and folded those in. So it turns out to be the fastest sampler you can use right now. But it's not really because it's Rust, because the other
It's
samplers.
because it's a clever implementation, right?
Yeah, exactly.
Yeah.
Yeah. So it's kind of interesting. So I'm just curious, like when we get to it, like what your thoughts on like why you have chosen to use Rust for your projects and things. So yeah.
Yeah, I think I'm pretty much on the Andrew's boat of like seemed like something different to do, and uh, no experience in low-level languages, so it's been a fun exercise to try to keep up and learn. But I think the novelty of leveraging two languages and how one complement the other and make things faster on one side. So that's what appealed to me, and why I joined the group.
And I feel like a
Awesome.
scam speaking here, Andres. Sorry, but
Yeah, go ahead, Marta.
I did join this group and then ungracefully exited. I just dropped it and I got busy with other things. I didn't have the etiquette to can even come one day and say, I'm so sorry, won't be able to join again. I had, except for Ronald, I think I have, met everyone else before online or in person. Actually, with Jackson, we worked for many years together. And now I work with Andres and I'm learning a lot from him. So when first, like, my reaction to, so why Rust? I think because of you, Andres, and the excitement that you brought to our expanded team, that kind of really, brought me interested. But then I also kind of heard that Jackson was into it, and the data science learning community, which I had met some people during a conference last year, and everyone was so friendly. And it's like, okay, sure, it's a great opportunity. At that time, I was actually with you, Andres, in the extender masterclass of Expantia, and I was not able to do it because of the time, I think. And this was kind of working better for me. So anyway, kind of long story short, I also kind of felt the same that Jackson said, that it was kind of amazing to me that just the language has so many things that have been extensions in R, like, for example, the package management system, targets, for example, in R is an extension, but then, in Rust, it kind of comes, more, baked, and type safety. So a lot of things that kind of really made me think, wow, this is such a cool language. And then I don't know if you guys here have seen Andres work live, but he's like just freaking incredible. And when he does it with Rust, he's like, he's so passionate that I know it's just really contagious. So loving to be here.
Cool. So I'll tell my story of why I got into it, because it's a little bit curious. So this was 2021. I was building a startup for doing some data analysis on medical records, and I mean, there's a lot of data analysis to do on medical records. The specific part that I was focused on is predicting the cost of different patient groups based on their historical data, right? So, a patient goes once a year to this sort of like I have no idea. There were so many combinations of things, but for example, can you predict if a person's gonna have a higher price with their cancer treatment than other patients, right? Not necessarily does this person have cancer or not, but is his cancer treatment going to cost 10 times as much as other patients? Was kind of the thing that we were trying to figure out. And we would sell that to insurance companies and hospitals as well, so that they could have fair negotiations and kind of don't end up losing a bunch of money. So that was sort of the what I was trying to do. And at some point, it was all cool in games when you're having fun with data and applying models and stuff. When the law comes into the equation, things change quite a bit. Because the law is like, there was this big paper, it's called Law 1174, I think, that is like 90 to 100 pages of rules that you need to take into account when doing patient contract, like when applying insurance to a patient group. And they are a bunch of kind of sort of decision trees that is like, hey, if the patient has this, then that, but if it has this, it's a bunch of like so many conditions that it was honestly really hard to kind of parse them all out in my head. I don't know how I did it. So many sleepless nights, but sort of got it going. But the thing about those rules is that they weren't really easy to map into something like a data frame, right? They were like, there's very nested decision-making structures that in R, the only way to solve them would be like either R6 classes that were like R6 class inside an R6 class inside an R6 class inside an R6 class, or maybe a list inside a list inside a list inside a list inside a list. And if you were to do it in Python, it would be kind of like a dictionary inside a dictionary or a class inside a class. It's kind of the basic concept. And you would think that working with that is a big headache in both R and Python, right? Like, imagine running validation over a list inside a list inside a list inside a list. Like, just 3 levels of nested lists are already a headache. Imagine 50 or 100 or even more depending on the complexity of the patient. So that was I can't do this in R. First, it's hard just to kind of validate what you were saying, Jackson, of type safety, right? Because I have a list inside a list and I want those lists to have a certain structure. Just validating that structure was already taking a bunch of time. And in terms of performance, it was, how do you go into a list inside a list inside you either do like a bunch of per map inside a per map inside a per map inside a per map, or you do for loops, and both options were pretty slow. When you're running it over a database of, it was I think 10 million patients, and those 10 million patients each had thousands of records. So I was running over data sets of in the billions of observations. I think in total it was about like 780 gigabytes of data. And running that in a list inside a list inside a list inside is it just wasn't gonna happen. So I was like, okay, I need to probably go into a different language for this very specific task. And I was like, I could do it in C++, but I really didn't want to. Right? It's like, I also thought of Java. My first programming language way back was Java, and I was like, yeah, I don't really want to type out Java again in my life. So I went like dabbling. Okay, what's out there? There's Julia. There was at the time, yeah, pretty much Julia was like the only data-ish language that was kind of it. But I have heard of Rust. So I heard there was this blazingly fast, as you mentioned, Andrew, language called Rust. Like, I'll try it out, right? And very quickly, I could describe all of those different nested possibilities as the data types in Rust. So if I took like the enums and structs and I combined them together, I was able to model in a day what I wasn't able to model in weeks in just like doing list inside a list inside a list, right? But I think you, Ronald, that you come from Haskell, like the algebraic data type concept. For that specific use case, you can kind of think of why it was really, really useful to have like algebraic data types for describing all of these possible decision making. So I modeled it and I created like the first version of the pipeline. Again, I didn't need to run it like hot. It was basically part of an ETL. And at that point, I think our extender wasn't mature enough to be able to write our library. So it was basically just part of the ETL, call the binary, pass in the Parquet file, and do the processing and kind of put it on a database. I think was the part that was doing it right there. And that's how I got into Rust. So that was my first experience with Rust. That was back in end of 2021. So I think the 2021 edition was just released. And yeah, that's kind of how I got into Rust. And from there, I just thought, wow, there's so many things that I can do with this language that I'll just continue doing it. After a couple of years, our extender started becoming something that was actually useful in production. So the R polars package, kind of bringing the polars bindings into R, and a couple other packages, kind of like, okay, this is possible. And then I'm gonna share. I don't know if I can share on chat a screenshot on, how do you call it, on Zoom.
Yeah, you should be able to. You can
But
just push the share button down there at the bottom.
yeah, I found it, and this was a screenshot from Rust Nation UK from last week, and it shows the growth of Python packages published with C++ and the Python packages published with Rust. And you can see that the trend is very clear. I mean, Python is becoming more popular, so both of them are increasing, but one is clearly outpacing the other. And the graph goes back to like 2005, right? So C++ had like a 15-year lead right there. So that just kind of confirmed my bias that this was kind of a good investment of my time to keep learning and to kind of advocate for. And here I am today. So in the process, there have been a bunch of tools built and a lot of things done, but that's kind of the big summary of why I'm here.
Awesome. That's fantastic. I like how it involved your kind of initial start involve types and having to check like like the idea of having a list, but you needed to have a certain structure. Like I mean I find I come across issues like that. I do a lot of Shiny, and so it's like often I come across things like that where it's like it would be really nice if I could just say like this is the general shape this thing should have, and I don't have to like write a whole bunch of validation code for that and like wrangle it back and forth. So I think that's interesting. I mean that's one of the I mean was one of the big kind of features of R as well, as like it doesn't have type, or you don't have to, it's not statically typed. Um, So it's interesting to me that that was kind of like the first thing that first jumped into Rust.
Andres, I'm curious because I think a lot of us here have experienced the R community. Oh, I'm so sorry, Jackson. I jumped in front of you. Go ahead. Yeah. Okay. And actually today with Jackson, we exchanged a couple of messages about, well, anyway, like just saying how nice is the R community, and I think I would like to kind of pick your own experience about, okay, how does the Rust community compare? Is it kind of developing on a good track, kind of in a similar nice direction as R, or or do you feel that it's more competitive, or I don't know, what do you feel there?
So I feel that there is a general Rust community, like what I would call like Rust enthusiasts, perhaps, is like just the people that are excited about the language and like all of the things they can do. And if you guys consider yourselves that, I have a bunch of talks that I could send you guys just to kind of get you hyped up. But Rust is in contrast to R, is a more general purpose programming language, right? So when you're going into R, you're going to find statisticians, you're going to find data scientists, you're going to find people that are at least tangentially involved with data. Meanwhile, in Rust, you can find people that are working on the Linux kernel. You can find people that are working on networking, on what you mentioned, like sampling with Monte Carlo simulations, right? And you're gonna find people in every single, how do you call it? In every single part of the software ecosystem, you're gonna find people that are enthusiastic about Rust, and you're gonna find like sub niches, right? Like this right here is like a little bit of a sub niche. So I think that the Rust community is very, how do you call it? Very enthusiastic, right? I think that's probably one of the reasons that it's had the growth that it has. People just like writing Rust. At least the people that like writing Rust a lot. I know people that don't like to write Rust, people that come from like 40 years of C++. C++ has been here since the 80s, right? It's a big change. It's a stricter language, but the people who end up liking it probably a lot. Which I think is very similar to R, right? There are people who absolutely despise writing R. And that's fine. That's that's them. Like, what am I supposed to say? But the people who like to write R probably like to write R a lot. I see the people that are attached to R really like it. So I think they are similar in that case, just that Rust being a general purpose programming language, you're going to find like many more niches that what R can cover just because of the definition of the language. I don't know if that answered your question, Mauro.
I was just curious also, like, because you showed the plot of Rust, nearing or overtaking C++ in the Python world, and I was wondering if you see or anticipate or think a similar thing is going to happen in the R world and like the RCPP backing and this kind of translation, or also if you even think there would be a value in doing that.
So I think it could happen. There is one barrier right now that I think is CRAN. So I like CRAN. I like how strict it is sometimes, but it's also not very welcoming to new technologies. Mauro and I literally just had a chat this morning about some warnings that the RCMD check gave, and Cran is really nitpicky about those sort of things, Mauro, right? So, for example, on the R universe package repo, is that how you call it? I don't know. Mauro, you probably have a better name for it, but yeah, on the R
yes,
universe.
they are universe, correct. And then they are multiverse, but which is kind of a newer casting. But yeah, exactly.
Yeah, but on the R universe and the R multiple, there are a lot of Rust packages that come from people in the geospatial world. So I don't know if you've heard of Josiah Perry. I've collaborated with him a couple of times, and he's a very well-versed Rust engineer. The whole Polars ecosystem is hosted primarily on the R universe, right? It's not really on CRAN because CRAN is like, yeah, this package is too heavy. Even Mauro, the Orb Weaver warning that we're getting, like, hey, this package is more than 15 megabytes, and it's like, come on, right? What year are we on? So yeah, I think on the Python side of things, it's like, first, it's really easy to publish packages in Python, so there's not really that much scrutiny, and the Python, like the main Python developers have embraced Rust into the ecosystem. So I don't know if you guys know the cryptography package in Python on the, how do you call it, on the standard set of libraries, because in Python there's not really one standard library, but on the standard library in Python, the cryptographic package is written in Rust. So Rust is literally in the standard Python implementation nowadays. So it's that there, on the R side we're not there yet, right? So I think, yeah, once we get like we coordinate CRAN and all of these parts, maybe we'll see that. But yeah, that's sort of how I see the thing coming on. But again, for people that don't, like, for organizations that don't necessarily publish their packages on CRAN, I think we're ready to go. Just that, yeah, CRAN is that one big limiting factor.
That makes it hard for certain types of businesses, like I'm in pharma, and like it can be a little bit more challenging to use a package that's not on CRAN. I think
Yeah.
it just kind of depends on the particular IT team and getting the right person and explaining how. Yeah, just because this is like GitHub only doesn't mean it's a security risk, you know. But that I can see that definitely being a challenge.
Yeah,
In
and
certain
again, it's probably a thing of having someone in the core CRAN. Is it called the CRAN team? I don't remember what the name of the
yeah,
core
I think
maintainers
so.
of CRAN, to kind of, okay, let's not enforce a version of Fedora Linux that is like 20 years old, that has a Rust compiler that is like 1.58. 1.58 is a very old compiler. It's like over 3 years old, 4 years old. I know there are some companies that still rely on really old compilers, but again, it's like there are some things that need to be kinked out. I just see, Jackson, you sent an article, right?
Just another article about how CRAN is holding R back. That's a
Yeah, and again, this is depending on who you talk to, this can be very controversial, very incontroversial. I love CRAN for what it is.
yeah. We don't have
I
to get
also,
too deep
I
into it.
yeah. But again, like Andrew, what you mentioned, like Python's adoption is still increasing, right? There are a lot of people taking on Python, and Python doesn't have a CRAN, right? So I think CRAN is a plus that we can have, and we can probably have like the very curated R packages, but they're, again, it's like industry is not going to stop adopting new technologies just because every single package is audited. And yeah, and those are opinions that people can have.
Andres, I mean, I'm very ignorant in the reasons why, for example, or Weaver, for example, is a bigger installation, right, than the typical R package. But then, how does that compare with, what if it was in C++, for example? Why are there so many packages that do use say C++, and do they also face like similar type of problems, or like is there any particular fundamental difference in Rust, or it's just a matter of like giving the community some time to adapt the tooling?
There is a very specific reason why. So for typical C and C++ projects, you use a lot of dynamic linking, right? So when you have to install the driver for PostgreSQL, for example, you don't bring in the C++ code for that. You install on your operating system libpq. Or if you are doing geospatial, you have to install on your operating system libgdal-dev, for example, if you're on Ubuntu, or if you're, every single platform has like their specific changes on how libraries are called. But you usually do a lot of dynamic linking. On the Rust side, there is some dynamic linking and there is support for that. But the typical way of doing it is just include those in the binary, right? In that way, you don't run into errors like, for example, when you install a package and that can happen on a CRAN package, right? You install our PostgreSQL, but then when you try to run it, it says, oh, you don't have libpq-dev installed. Please do sudo apt install libpq-dev, right? Or OpenSSL is a very common one. So it's like, please install libssl-dev in order to install this package. So that dynamic linking, it takes all the dependency management of the libraries of the into the operating system instead of the language like Cargo or doing the heavyweight. On the Rust side, you typically want all your dependencies to be also written in Rust. And that's good in a lot of senses because it's a more optimized binary. You don't rely on dynamic linking. You can install that R package on a system that doesn't have OpenSSL or a bunch of other things installed. But that leads usually to more source code, right? CRAN also doesn't allow for, or it allows for, but it's heavily discouraged to a point that it's basically not allowed to have the installation process require an internet connection, right? So you basically have to vendor the source code of all your dependencies into the Weaver package, for example. So Weaver includes the source code for I'm trying to think of which dependencies Weaver has internally, but for example, Weaver is a very bad case because it doesn't really have many dependencies. But the standard library does need to be included for Windows, Mac, Linux, and all the operating systems. Something like Polars has HTTP connections, so it does connections to the network. It has to have SSL integrated because you have to be able to interact with data warehouses run on Google Cloud Storage or Azure Cloud Storage. So it also has to include libraries for interacting with Azure, interacting with Google Cloud Platform, interacting with AWS. And all of these dependencies need to be bandered inside the package. So, and usually, again, for example, SSL has platform-specific source code. So there's source code for Windows, there's source code for Linux, there's source code for Mac. So you have to include a lot of source code inside your package. And that leads to, bigger. Again, we're not in the 90s. We probably don't need to optimize for disks, for disk utilization. But that's kind of like the way things have been for a while now, and that's kind of probably how it's gonna stay on the YAR side of things. That dynamic linking is the answer to that question.
Andres, that basically means like I could have some library, like you said, like a Postgres driver, say. I have that library like as a binary. I can write my C++ code to say like go look into here to do these things. Like where you wouldn't have to like include, you don't have to include that driver like as a dependency of your package. I don't know if I'm explaining it right. I'm trying to make sure I understand.
So use dynamic linking on the Rust side of things is what you're saying, right?
No, just generally, what is dynamic linking? I feel like I have a vague idea.
I'll try to explain it to the best of my ability. Ronald, since you've dabbled into C++ and you probably know how this works as well. If I say anything wrong, or if I'm missing something like a key piece, just help me out. So when you're compiling C or C++, you bring in libraries, and I call it libraries, but it's not really libraries. You have to include header files. Those header files are files that tell you there's some functions that have these signatures, and they return whatever type. Maybe it's a pointer to some sort of memory. Maybe it's a struct. It also has the struct definition. So it has like all of the data that you need to be able to interact with that library, but you don't actually interact with that library. When you run your program, the program asks the operating system, hey, operating system, I'm looking for this library called libpqdev, or libpq, or libgdal, or libssl, or whatever. And the operating system like, hey, here is the library. Here is the function signatures that I was kind of working against, and it kind of does the mix and matching so that you can actually run the code that you were intending to run. And in a way, it's similar to how our libraries are called in dynamically, right? So you can write source code in R that assumes you have dplyr installed, right? But you don't actually need to have dplyr installed to kind of run that code, right? It's just gonna error out. It's pretty much the same, right? So you have libraries that are managed by the operating system that your program dynamically loads when it needs to load them, typically at the start of the program. And yeah, that's kind of the best. It's one of those things that's weird to explain. I don't know, Ronald, I don't know if I said anything wrong, or if there's anything else you would
I
want to
think
add.
that's basically. I mean, linking is just the process that compiler does when it takes the symbols you've mentioned in the, for example, in the include files, it tries to figure out what those symbols, what source code these symbols actually can correspond to. So static linking, which is the kind of the normal way to do it, is you actually have the source code in some other file and it finds it in there and it links it together. Dynamic linking, it just puts a little stub and says, well, when we run this later, we know that somewhere in your system there's a compiled library, a DLL on a Windows machine, or an SO file on Linux that has the compiled code that the symbol corresponds to. And we'll look it up then dynamically, and then we'll make the right call. So just it's the plus side is it avoids having to install the same library over and over and over again for every application.
Yeah.
But I'm sure you've heard of things like DLL hell on Windows machines, where you have one version of DLL, but it's the wrong version, and you don't know why it's not working, and you need the old version, but then that'll break your other program. And I don't think that happens as much anymore. I think they've solved most of those problems, but that used to be a thing, 10
No,
years ago.
it's still a thing. So for example, I've had that error with V8. So for V8 for JSONLite.
Yeah.
If you're on an old version of a Debian, I don't know, you've went to like an old version of anything, you're probably gonna get some error because it's like, hey, I need V8 version 12. You have V8 version 10.
Yeah.
But I just want to install the package. So Rust code tends to be more portable at the expense of disk utilization.
By the way, we are all heading in that kind of direction, aren't we? I mean, right now, like for example, running Python, I usually have like, I don't know, I have like 12 Pythons on my computer because
exactly.
And each one of them has the same pandas, polars, whatever, installed over and over again for different versions for every project I'm working on. It's fine. It's better that
if
way.
you use renv, you have the same thing.
Yeah.
If you have rig, which is written in Rust, if you have rig for managing R versions, you have the same. And for every R version, you have its own library folder that it points to. So disk space, again, I find it funny that, for example, Crank complains about a 12 megabyte project. I know it's an organization that does things out of the kindness of their heart, and I know infrastructure isn't cheap, but there are a lot of companies willing to probably. I know Posit hosts binaries, precompiled binaries, right? So companies are definitely willing to sponsor infrastructure. So I don't know. I think it's things that we could work out.
It's something they should talk to like the pip people about. I mean, know that the pip people for Python are I think it's the Python
The
backwards.
PyPy, the
Yeah,
Python
PyPy,
package
that's
index.
it. They're working on a new protocol where you host like the binary parts in a separate place in some trustworthy way. So you just have only the header parts or whatever in the official repo, but then it links with, using signatures, whatever, make sure you're not getting misdirected to somebody else who hosts the meat of it somewhere else, the binary part, especially like the R packages. Or it's the same problem that's happening there too. These things are getting bigger and bigger and bigger, and they're like, we can't have these giant packages hosted anymore.
Yeah, absolutely.
So,
But he also probably users are not going to use the whole package index, right?
right.
So us at Expantia, we do a lot of POSIT infrastructure implementations with different clients. And for the Python part, there's usually a set of curated, approved by the company. For example, in banks, they need to approve what PyPy packages. And I'm guessing in pharma, it's similar. These are the packages that are allowed. So you nitpick from the PyPy, which is like, I don't know how many hundreds of thousands of packages. You kind of nitpick which ones. So you're probably gonna have some caching right there. There's a lot of things right there.
Yeah, I just remember this. They're calling them rim because in Python they call them wheels, which is host
Yep.
the binary. So they're talking about having the rims be and the hubs be separated. So you have the hubs hosted. Some of the big hubs, you have like the rims. They're like the piece that you keep on the Python.
That's a cool analogy. Yeah.
I might have that
Jackson.
backwards, but it's something like that.
Yeah. Jackson.
Yeah, I have a faucet specific question
Go
it's
ahead.
cool if I jump into that. So I was curious, I mean, again, because we screwed around with one little R extender pedagogical project to sort of see how to integrate things with R and Rust, and then I noticed in Faucet, you're not using FFI at all. Like it's a process-based system where like Rust just spins up an R script process and R is handled totally separately. And I was curious, like just your your thought process that led you to that design choice and kind of like the trade-offs that you considered when you went that direction.
Yeah, so R is not thread safe at all. That's the answer, right? So I would rather have the operating system and handle thread safety. And I mean, like system processes are very powerful. So, right, you can send a lot of signals to different processes. You can, like, if you have the handle to the command, you can do a lot of stuff. From R, you really can't do much. You just call the system command and you kind of just wait for it to run. On Rust, you do have a very powerful handle over system command. So, for example, if I need to restart Faucet, I can have like a graceful shutdown. So I can like, yeah, let's intercept all HTTP connections and wait for all of them to finish. And that's something you can do without having to run into handling R thread safety, which isn't thread safe. That was basically the design decision, and the overhead really wasn't that big. Again, Python has GIL, but they're even removing GIL. So Python is ahead in thread safety and letting packages like fast API or letting like external packages be like, okay, Python, don't worry about thread safety, I'll worry about it. So I would love to have sometime in the future to have R is like, hey, I'll give you thread safety and let Tokyo and Rust handle it, for example. That would be awesome. I hope we get there someday and we can have like much faster Plumber or much faster Shiny or much faster anything that's asynchronous in R. For now, we kind of don't we can't really have much else from that. But yeah, that's it. That was the decision process. Yeah, Ronald.
I actually just had a question too about Rust in general. So, as somebody that's learning Rust, I'm curious about your process. Like, do you like one of the things we kind of got bogged down on the end is like, oh, all this stuff about unsafe. I'm just not ready for that yet. I just all these things we've learned, we want to like practice with those a little bit before you start getting into the unsafe Rust or macros. So my question is like, how often do you find yourself diving down into the unsafe Rust and macros and these kind of advanced features like this?
Only when I need to, or
Well,
only when
course.
I like. I would say I'm not a bad unsafe user. So right there you need to go into your that's when you need like, okay, I need to be very careful with what I'm doing. It's unsafe, or it's called unsafe for a reason. In Orb Weaver, it's an R package that we have for graph analysis. I use unsafe because I wanted to extract the last little bit of performance, and I had like these buffers that I wanted to reuse across calls. And I knew, since it was an R package, that it wasn't going to be threaded, right? So I didn't need to worry about thread safety because it's going to be called from R, and R can really only run one thing at a time. So given that guarantee, I was like, I'm just going to use unsafe. Like, and I have like some buffers that I have like this unsafe get buffer, which basically just recycles a buffer with minimal overhead, which is basically just working with raw pointers at that point. But it's like that's one case where I have had to use unsafe. Macros I do use in Orb Weaver as well, because I have many implementations of graphs. So there's like the directed graph, and there's also the acyclic directed graph. And both have, for the underlying Rust implementation, they have different implementations, right? I can use, if I know it's going to be acyclic, then depth first search is faster than a breadth first search. That's just it's a faster implementation for that. Since I don't have to worry about cycles, I can use that much more easily. So in that case, I created this macro that would implement all the methods for every single type without having to rewrite method 1, method 2, which is a lot of boilerplate. So I was like, I'm just going to make a macro that implements this. And yeah, I think I've used procedural macros a couple times. One for polars, and it was this very small thing for polars, and I had to use I used a procedural macro to make it easier. But I mean, it's not your everyday Rust, right? And it makes most sense when you're like a library developer, not like an end user of Rust. Like, oh, I want to publish this for end users. I want to make it as fast as possible, or I want to make it as ergonomic as possible. It's that sort of thing.
With that Orb Weaver thing, did you so you guys wrote the Rust library and then wrote the R library on top of it? I mean, is it intended to be used as a standalone Rust library too, or is it just for the R package?
So this is the cool thing. Rust is very portable, as I mentioned, because of the static linking and all of this stuff. Meaning, R isn't the only frontier for us. So Orb Weaver was first developed as a solution for a specific client that we were running, again, a couple tens of millions observations database of graphs that represented a very complex financial structure. And we needed to do some live manipulations of that structure in Shiny. So we needed to use that to query some data, and the user wanted, like, this client is very performance sensitive. So they were like, yeah, I'm clicking and it takes 1 second. This is not fast enough. So I was like, okay, we're gonna need to go ahead and do some lower level stuff. And we wrote the Rust library for Orb Weaver. And what ended up happening is that since it was Shiny, we needed to do both data intensive stuff on the server, but we also need to do client side things, right? We needed to have like a very responsive user interface. And what we ended up having is that, hey, we need to implement the graph algorithms on the server for running data, but also on the client in JavaScript.
Oh, brother. Yeah.
So if we wrote an underlying Rust library, we could compile that library for R and compile the library for JavaScript as well with WebAssembly.
WebAssembly, yeah.
So
Cool.
we have it's on the GitHub repo. The WebAssembly one has many less requirements, so it's really not. It's not that it's not maintained; it's that it just doesn't have many updates because there's no need for any updates. But on the Expantia GitHub, there is Orb Weaver WASM, which is the WASM compilation of the Orb Weaver package. There is the Orb Weaver R for like interacting with it with R, and there is the Orb Weaver RS, which is the underlying Rust implementation.
And I'm sorry, I don't want to
Go ahead.
sidetrack too much, but I have some graph problems I'm trying to solve too. So I'm actually particularly interested in this. You guys didn't find already some existing Rust library that did graph stuff, and that's why you. I know there's like pet graph.
We could have, just that they're
Heavyweight.
no, just how can I say this? Sometimes you need very specific features,
Mhm.
and kind of having full control over the implementation really helps out a lot in that sense. So, for example, we're using Weaver now with another client, and the other client says, "Hey, I need to do this specific thing over my graph." And it's like, okay, what if an underlying Rust library doesn't implement that very easily?
I see.
And again, we needed
Gotcha.
maximum performance. So maybe you could do it with another Rust library and that specific use case that they needed. But if we wanted to squeeze the last little bit of performance, then we would have to go and modify the underlying library, which doesn't sound fun because we would need to integrate into a new code base. And the graph algorithms are so well documented, and they are yeah, it's like it just made sense for us to do the implementation outright.
Cool.
And that gave us the fastest library in R for for interacting with direct graphs. So
And
yeah.
there's just to be transparent, like is that a kind way? Like who else was at your level writing Rust when you were working on that project, or like, was it just you really? And
in Expantia.
yeah. I'm curious.
So Pierina used be, and I don't want to talk about like Pierina without having her, but she used to work in cryptocurrency before Expantia.
Oh wow.
And crypto is like, again, portability of this stuff. Smart contracts are usually written in Rust. So Solana and there are a bunch of other blockchains are written in Rust. So she knew quite some Rust, and we're both in the same project. So it's like, okay, this makes sense. We can both edit this code base. So yeah.
By the way, for this group, Irina is a medical doctor who quit medicine to become a data scientist. It's like it's a pretty cool bunch of people.
Yeah, Jackson, go ahead.
Yeah, so just thinking more about the language generalizability like discussion that we were just having, and going back to Faucet quickly, like it seems there's very little that's like needs to be R centric with Faucet, right? Like it seems like it could be generalizable to like a fast API or other elements. I'm curious, like if you see any value in extending it beyond, you know, the standard like QMD Shiny kind of system that it currently is set up in, or if there's value in doing that, or if that's already a solved problem, so it's just not worth
Is
not
that
worth extending.
Python has so much tooling already
Yeah, that's what I
that
figured.
it's like, how much value can I give to like the community
Yeah,
given the amount of effort, right? So I
totally.
could generalize to Python, Fast API, and that, but like Fast API already has some very good asynchronous primitives, and they right. R on the other hand doesn't have very like multi-threading in ours. It's very there's a lot to do, right?
Totally.
So giving a little bit back to the R community gives a much bigger reward for the community, while doing that same effort on the Python side, unless you're doing like UV, right, or
Mhm.
you're doing one of these big
Right,
projects on the Python side, which again, Rust is also making a very big impact on the Python tooling side, like very very big, and it's probably what things are gonna go forward for, but yeah.
I guess a follow-up question on that is in the R world, like in the Rust as infrastructure for our universe world, what do you think the next or the another project or the next kind of big infrastructure topic could be? Like I can imagine a UV replacement for R that bundles REnv and deals with all of that, or yeah, stuff like.
So I've wanted to do this for a while, just that it's such a big project that I haven't had the time. And Mauro, I know you know Pack, right?
Mhm.
But Pack is not a one size fits all solution for everything, right? So if you see the on the Python side, you have UV, like and there was also Poetry, I think was another Rust implementation as well of like So there are a bunch of how do you call it of tools trying to tackle the same problem in Python, which is cool. That means there's competition. That means the better one's gonna come ahead. On the R side of things, I feel like there's still a lot of segmentation on how to do different things. So if I want to bootstrap R packages or bootstrap Progress, you use this, right? But if you want to install packages, you use RM or remotes or pack or packrad. I guess there's still people using packrad. There's a big segmentation on the on every single possible thing that you can do in R, which I think is it's cool that there's so many different communities for doing specific things. That also means it's sometimes not that easy to get into the workflow of developing R, right? Mauro here is an expert in that. He knows a lot on how to build R packages and all the workflows and use this and there's so many things that you can go into, but not every single person is Mauro, right? On the raw side, it's like, oh, cargo run, cargo build, cargo doc if you want to render the documentation. So, right, if you wanted to, on that, like, I don't know, in the R side, how do you even build an like the site for the documentation? That would be like DevTools build site? No, that would be package down build site.
Package down. Yeah.
Package down.
Exactly, right?
Probably functions in DevTools as well.
And there are some in DevTools, some are in package down, some are in use this. Right. So I would think if we could have a CLI tool that has formatting, so there's Air that just came out by Posit, that's also written in Rust, right? So if we can integrate Air, package management, and RM, and to have all of that in a single package, that would be amazing. And instead of having different commands for everything, that would be I would say that would be like a very huge plus. But someone has to try to create an effort for you. And if you could unify rig, like the R version management, R dependency management, R formatting, R running, like everything in a single CLI, that would be amazing. That would be a very big team effort, and like I couldn't do it by myself. And that's one of the things. Like, hey, if there's ever an initiative to do the UV of R or the cargo of R, that would be, I think, probably some of the best things that could happen. But Mauro, you probably have a differing opinion. I don't know.
No, I love it. And also, like, in this specifically crowd, I think everyone is probably more knowledgeable than I am in ours. It's a pretty selected crowd. And also, I think we're coming to the end. But I was kind of curious to kind of ask you maybe a quick one, which is kind of like looking into the future and considering that, you know, the Rust community seems to be like pretty niche as of today. I wonder, you know, what that meant for you as someone like learning the language, to kind of see what's the road ahead for us, right? That people who are interested in the language, is that, you know, niche aspect something that has some barriers but also some opportunities? So how do those things, you know, balance in your view? Roadblocks and opportunities for Rust,
So
particularly
it depends on how we define niche. Like, is C++ niche? So if C++ is niche, then Rust is probably will always be niche, right? Just
That's a good point,
is Java niche? I wouldn't think Java is niche, but right. So I again, in Rust Nation UK, there was this talk by the CTO of Microsoft Azure, and he said in the talk, and there is no more C++ in Microsoft from now on. So all the code bases that already exist, right? You're gonna keep writing C++ to maintain them. All new projects are gonna be in either a higher level language like C# or Python or whatever, or it's gonna be Rust. So if it's systems level language, it's gonna be Rust in Microsoft from now on. And he has a very cool talk that shows kind of the roadmap of Microsoft's adoption of Rust. So if Microsoft's going to replace all C++ for Rust, and I'm guessing all the other big tech companies, if you go to OpenAI and see their stack is Python and Rust. If you go to XAI, it's Python and Rust. If you go to Anthropic, they don't say it openly, but on the Java openings, they say Rust. Right? So there's this trend. And again, it's probably always going to stay at a systems language, right? It's probably never gonna be Python. But if that's niche, then it's always gonna be niche. If you consider like the mainstream adoption of a systems language no longer niche, then it's probably gonna, in a couple, I don't know if it's a decade or 5 years or 1 year. I don't know when, but it's the trend doesn't seem to be going the other way.
Until the next language comes out, but
But let's wait 10 years. In 10 years or 20 years, maybe things will change. But
I hear a bunch of stuff about Zig. I don't know if that's
yeah, so the CTO of Microsoft kind of mentioned Zig in the talk. It's like, hey, there's this new language that's better than Rust. Like, okay, when is it gonna be ready for production in Microsoft? So Microsoft has been working in for Rust over 10 years now. And it's like, okay, this is the moment. Rust is ready now. Let's give Zig 20 years. And maybe in 20 years, Zig will take over. But maybe in 20 years, there will be another language that then overtakes Zig. But 20 years is, in 20 years, Java took, what, 15 years to kind of become the industry standard. And yeah, things move fast, but they also move very slowly, right? The things that stick take a long time to stick. The things that don't stick quickly. So let's give it time. Again, Python's been here since the 90s and still growing. So let's see how things shape out. Cool. I have to leave for another meeting. It was so lovely to talk to you guys, and let's keep in touch. And I just joined the Slack, so I think I'll be chatting over there.
Awesome. Thank you again so much for joining us, Andres. We really appreciate it.
No, thank you guys so much.
Thank
And
you so much.
don't worry, you write me anytime, send me a message. And if you guys want to learn anything or talk or whatever, I'm open to anything.
Awesome.
Awesome.
Thank you.
Well, I'm
Awesome.
sure we'll take you up on that.
Cool. See you guys. Bye-bye.
Bye.
Thank you both.
Bye, everyone. Thank you.